how to cook without cooking. It's a bit late in the evening and it's been a long day, so I think the last thing that you want me to talk about is food, but please bear with me a little bit. I still want to ask you this question, especially to maybe working parents. It's kind of like the dream to have this device that can cook for you without you making a lot of effort, and ideally diverse food, and then also ideally the one that kids would like. And in forecasting, which is what I do at Zalando, we ask ourselves the same question, only in terms of how we can forecast without actually training. And actually, we saw this a little bit today at the very first talk, so I like that I kind of closed the loop now. It's only that we saw how to actually predict any machine learning task with a pre-trained model, with the tabular large language models. And the cool part is that the same kind of thing exists also for time series data. So imagine you giving some covariates, you give some historical data, you plug it in the system, and as an output you get the future values for your sequence. It sounds amazing, but it's a question, is this possible? And we explored this question a little bit, and I'm happy to take you to the journey that we had in the last year on this topic. So what will we cover in today's session? I will share a little bit about foundation models in forecasting, what are they and how they appeared. Then we will speak about zero-shot versus fine-tuning, what is the difference, and what do we get from each. And then we will speak about something else equally or even more important than accuracy, that is stability. And here I will share also some experience on using LLMs to help myself as an applied scientist to speed up my work. So here, on one hand, this is just a corporate slide. On the other one, it really shows that we love forecasting and also that we need forecasting because, you know, all Zalando, we are a leading multi-brand fashion online shop, and at the same time, we operate in more than 25 markets, and we need to know what we expect to happen in our online shop. So we need to know what kind of demand and how much demand we expect in the next up to 112 days. And more importantly, we are not interested only in demand in terms of revenue, but we are also interested in how many items we expect, how many cancellation rate we expect, what will be the return rate, and so on. So in the team that I worked on aggregate level forecasting, we were forecasting 9 KPIs, both on daily and weekly granularity. And as you can imagine, this is, a bit of a task, right? At the same time, here, just a little bit of a historical overview of how we used to do this in the past. So, for example, in the beginning of the 2020s, and even I think up to today, statistical models are very much loved by forecasters. Then there were also transformers, then trees, for example, and so on. And then somewhere with the rise of LLMs, as I already mentioned, the special models which are specialized and trained and made to work specifically for time series started to appear. So here you see some examples in 2024 and 23, like Llama and TimesFM from Google, then Chronos, TimeGPT from Nixla. I think many people working in forecasting know the Nixla library for all kinds of forecasting algorithms. And then in 2025, we said, okay, we really have to try out. Is it just a hype, or are these models actually working? And luckily, we had the chance to do a bit of focused and intense research sprints. First, we had one hackathon in May. Then we had another 10 days research sprint, and finally the best outcomes went to production in the beginning of this year. So I will take you a little bit to this journey to show you what we tried and what worked and what did not work so well. First, about the hackathon in May. Here we were curious to just explore everything that we can find, everything where there was open source code, and then we tried different models. At the same time, we compared them with our baseline, with our best production models, and with some other classical benchmarks. And we focus here on only one KPI, that is GMV, gross merchandise volume, and in three markets, main markets, Germany, Austria, and Switzerland. And we tried also to fine-tune those models. Covariate integration was wished, but not really present. And we then got actually the Business Potential Award at this hackathon because we really showed that there is a potential in these models. In December, we actually made a focused research sprint where we only chose Chronos 2 as the kind of only model who was offering integration of covariates. And there we explored then forecasting not only one KPI, but all the KPIs that we have and also all markets. And also we try to look for best covariates which we have and see how that can improve. And let's see what were the conclusions. So in the 3-day hackathon, on one hand, it was nice that we can get some good results which are close to the classical baseline. So it was not a fully rubbish, let's say, even though there was zero effort. But at the same time, this was not enough to put something into production. And as I already mentioned, those models would take the historical values of a certain KPI, or certain target variable, but unfortunately, it was not possible to give additional context that could help make a better forecast. And as you can imagine in the business, this is very much needed because we have lots of plannings, lots of information that we know about commercial activities, discount rates, and so on. And it's nice to include this information. Sorry, just a second. Then in the 10 days research sprint, actually we focused on, as I mentioned, we measured the accuracy of GMV, but actually we tried out forecasting even the other KPIs, and we saw an improvement across all markets. And this was really amazing. And here it's important to know that we are forecasting the gross merchandise value, the demand on a country as a whole. Other colleagues were exploring also Chronos 2 for forecasting the demand on an article level. This did not work so well. And the most interesting part, and I will cover this also a bit later, is that fine-tuning was not particularly helpful. So let's see, for those who are interested in the architecture themselves, what's so special about Chronos 2 and what I think made it be so successful and so different than the other architectures. So here, the Chronos 2 is a model developed by Amazon, and it is encoder-only architecture which is having two types of attentions. One is the time attention, where the model is learning from the time series itself and the historical values and the relationship between them. And the other one, which is new one, that is the group attention, which means that for a fixed period at the time, the model is learning how were those relationships of the different, for example, different countries, different KPIs, different covariates, how do they learn from each other for a fixed period. And both of these in combination give us a very good and powerful model that is able to learn well the structure and then make the predictions. Another thing that is very powerful, and you might find it familiar because it was mentioned also today, is the same thing that I believe made tabular TabPFN, for example, as very successful, is that astonishingly enough, these models are trained only on synthetic data. And this is somehow, I think there was also one question, it's hard to believe how and why this is possible, that we are learning the future of some actual data that exists from the business, or it can be from anything, without ever seeing such a data. And it's very interesting to see. We don't have time to now go to the details, but actually very nice and innovative ways of data generation were used, including even causal effects and even including delayed causal effects. So really trying to mimic what happens in reality. And then you see we have 100 billion and more series. So it's really a lot. So it's kind of trying to explain the world with all its possible outcomes. And then what happened? So in the first hackathon, we were thinking, okay, these models are not working so well. We have to fine-tune them. And I had even like an idea of building a foundation model for the fashion ecosystem or something like this, because I was thinking, okay, we need to train a model which knows how fashion e-commerce data is behaving. But with the rise of foundation models which are trained on synthetic data, it turned out this is not needed, because the models already kind of know, let's say, and then with the right context, we are still giving, that is historical data and future and past covariates, is able to perform already very good. So no need to unopen the box. This is really cool. And then let's see if this can also help us, bridge some gaps and improve the way we operate. So what do we have? On one hand, as I said, 24, already more than 25 markets, 9 KPIs, multiple granularities, both short-term and long-term horizon. We have a variety of models, each of which requires, first of all, training, then maintaining, optimization in case of not well performance, further exploration and improvement. And this requires a lot of effort. On the other hand, what I'm not sure if it was clear from the Chronos 2 model, the Chronos model is giving us an opportunity to forecast all these KPIs at once, also all the markets at once. The only thing that we don't have is that we cannot forecast both daily and weekly together. But we can still reduce the complexity. And if the accuracy is of similar, level, then maybe we can just substitute everything, right? So, I mean, we are still not there yet. But what we managed to do is that for those KPIs where we saw a very big improvement from the classical or the current models, we did deploy the Chronos 2. But then I want to say, even if we, let's say now in certain period in the future, we have exchanged all the models to Chronos 2 because our accuracy is great, can we stop there? And is this actually then kind of the end? And here, actually today I think it was a second talk from Gerhard, there was a very nice quote saying, accuracy is only the beginning. So I really like this because this is true, I think, a lot, especially in the e-commerce setting, because we as scientists are interested in the accuracy. It's something we can measure, something we can compete with each other to get better. But is this actually what we want? And is this enough? The problem is that our stakeholders, our business needs not only accurate forecasts, but needs a bit more than that. And what it needs is, first of all, the performance has to be there. But second of all, it needs stability. So if you imagine, I am forecasting now my demand, let's say 4 weeks in advance, because we need in our logistics warehouse to plan how many workers we should have there. And I give some number, and then I'm like, there it is. You can go ahead with the planning. The same with customer care, same with marketing activities, and so on. And they plan and fix a contract, invest some money in this, and then 2 weeks before the start of that week that I forecasted, I say, oh, wait, sorry, my forecast just changed. The numbers is 30% less. I mean, it's a big no-go. First of all, the trust in the forecast is shattered, because they're like, why is your forecast so unstable? Why they can be decided what is better? And even if I know this number is better, it doesn't help me, because there is a huge penalty that I have to pay now to, let's say, get more help in the warehouse or less. So that's why it's very important to have a forecast that's not only accurate but also stable. And then even if we are convinced, the second question is how we measure it, right? Because at the end of the day, again, we only have the data, and if we have a mean how to measure it, only then we can discuss and make a choice, data-driven choice of choosing one model over the other, because maybe the second one is more stable. So then I was lucky, I think, to find this paper called On Forecast Stability, which we covered. I will show you how actually the process went now to introduce this to our working line, because before this we were not really measuring. We were more hearing from the stakeholders complaints that the forecast was not stable, but we did not really do much about it. And now there was this very nice paper which clearly defines what stability means. And there are two types of stabilities one can define. One is vertical and one is horizontal. So one that I already talked about is the vertical stability. So is the forecast for a given week, let's say in the future, changing a lot as I get closer to that forecasted week? And the horizontal one is like, if I'm forecasting for, let's say, next Wednesday, is the forecast around those days, like the Tuesday and Thursday, around the same? So this is more about expectations, because we know that usually our work, or at least our use case, or for many other industries, so that you cannot expect a lot of jumps around. And then they introduced some nice metrics how to measure this. And how would we then usually go for if we found such a thing and we now want to try it for our data and for our models? So in the past, usually what we would do is like, I found this paper, super nice, I start reading it. Then there is one thing that I would usually do, that is check the end of it and see if there is an open source code for it. Now this is actually, after I had prepared this presentation, I found these papers with code, a new kind of initiative, which is collecting all papers which have code. Super nice tool. So then you can check over there also for the right paper that you already can be sure that it has code. And then we have a research paper reading group on time series. Then we would discuss it with other applied scientists to see if we see some benefits or some hints of why this cannot work in our case. Write a mini research plan and then go and try this out. And then from taking, even if there was a code or if there was not, writing it, then trying it with some synthetic or toy data, then trying with our production data, and get some results that are gonna actually give us tangible results in how to then behave. Should we keep or switch the models and so on? It would take, I mean, at least some weeks, right? Let's see if it's about simple implementation. And now it happened so that actually I was lack of time because I needed to switch teams, and I had to either give up this topic and hope that the team who left will try to cover it, or try to see how much I can go with it using agentic coding. So we were also a bit encouraged by the management to use up all our tokens in Opus, for example, and I was like, okay, now it's my time. And let's see how that went. So here is exactly the flow, let's say, and I'm here so to say, not an expert in the field, and this was done end of February. I think nowadays there are much more advanced ways to do this, and I have one link then also afterwards of work where how one can do it even, let's say, cooler, but this was very straightforward. So going to a planning mode in using Claude Opus and explaining what I want to achieve, but then again, giving exact context, that is my repositories, my data on S3, on AWS, like where we store the data, where we store the models, everything that is needed for building a solution that will work directly with the data that we have in production. So not a toy example, but really what we actually need. And then in the planning mode, I think it's very important to not avoid the agent or the mod. I mean, in this case, like just like Claude, to avoid it making a lot of assumptions, because it will try to convince you that everything is there, even if you ask for things that you know is possibly cannot know. It will make up things, right? So the hallucination is a thing. So we have to make sure that they are telling us, okay, these are my assumptions, and then we make sure that these assumptions are actually correct, right? Then we refine some strategies and what we want to achieve, and then go to execution mode. Here is where we can have a coffee. And let's see what, actually, yeah, here I just have on the right side, like the execution, the plan, and then what exactly it is planning to do. And then what happened afterwards is that I've got a notebook that is able to calculate me this forecastability, but I still have some time and still had some tokens. And then I thought that we recently developed a Streamlit app, which is like kind of a dashboard for monitoring our forecast and the accuracy of it. And I was like, okay, but to make sure my colleagues are going to use this, how about I also build Streamlit dashboard that is together with our current forecasting monitoring, which is going to measure the stability of the forecast day to day as we have as we are using it. And again, in the same manner, this was actually not so difficult. I had to only dig out where is the Streamlit repo, because I did not know. I had no idea about it, but it worked. And then when I had a little bit of time, I made it write documentation for my Streamlit app and from my colleagues. So it was like I think the ideas keep on coming once you are in the flow, and it's very powerful because it is on one hand saving a lot of time. On the other hand, I don't think the time is saved, because then I get to get more ideas of what else I can do, and then it's like almost impossible to stop. So it's not so easy, but here I can show you a little bit now back to the stability and to the mathematics. This is the dashboard, and we see that we can see on one hand the accuracy, then also the stability. And the other nice thing that this model had was that it gave an opportunity for post-processing to improve the stability. And this I also managed to show in a graph here. So on this graph, we see the stability here for a given week in the future. If you see like a line that is full green, then it's like more or less okay. And then here you can see there are some periods where everything is pretty red. So that means that there are some seasons where our forecast is really not stable. So then this would be something to take a look at. On the other hand, what I don't have here I'm only comparing or calculating the stability of our deployed model. Another even more important thing is like once we have developed a new algorithm and someone wants to go and deploy it, it would be nice to compare then those two models and see not only how they perform in terms of accuracy, but compare the stability metric as well. And now also here we can see the idea with the post-processing for decreasing the stability. So the solid blue line is showing us the accuracy, and the light blue and dashed line is showing us the stability. And here we see this interpolation weight on the x-axis is the one that is giving us, it's like a tool or a parameter to impose more stability, because you see here how the stability is growing as we increase the parameter, but at the same time the accuracy is dropping. But if we are wanting, and moreover, if even our stakeholders are willing to give up a little bit of the accuracy in order to gain stability, with this graph we can see what would be the optimal parameter and then tune it so that at the end kind of everyone is happy. And then another thing that I like in my work as applied scientist is that LLMs really love markdown files. And then if I have done my work in the past also, usually it's not enough to have even a great model or this new accuracy metrics or stability and so on. We have to share our knowledge. And this would also take quite a lot of time to write the report, to share it with the colleagues and to explain everything in details. Nowadays, this is quite easy to build using LLMs again. I think here the only drawback is again that you can then start to generate more work than people are able to read, and we still have to go through it and read it and make sure that it's correct. So it's knife with two sides, but still much helpful, I think, if we know exactly what we want to achieve. And then again, also some hints to share with the colleagues how we can then use this in other areas, because I thought that this is an idea that can be used in general for any research idea, for any paper that we have found now. The way from research to example of usage within our data and within our ecosystem is much shorter, the time of build much shorter if we take advantage of the LLMs. So what do we see? I have two kind of conclusions for the end. Now, one about the foundation models and the zero shot. The zero shot in forecasting, yes, it's real, but the zero effort, this is not. And here it's similar with the cooking, like we can have the best machine, but the ingredients still matter a lot, right? And again, here the foundational models in forecasting, they can work very well, but they need to know our data. Even if we don't train, they still need to know the historical context. We still have to choose the covariates that we want to give. And then again, we still want to make sure that the data that we are producing at the end is usable for the business. On the other hand, as we saw, we can increase further our abilities. We can introduce new metrics. We can extend our models. And building the ideas, like coming from an idea to execution, is actually becoming fairly easy. But at the same time, this is a question of, are we actually building what we need, right? We can have a perfect solution, but if it doesn't capture the needs of our business, it is then, not to call it useless, but it cannot be well adopted. And we have seen it a lot, right? So high adoption only comes with understanding of what kind of problem are we trying to solve. And I have seen this a lot in forecasting, that we try to solve a forecasting problem, but actually we don't have a forecasting problem. So I think coming back to the question what we are trying to solve, and even then if we go to analytics and all these metrics, how we compare, how much we check, what does it mean the model is stable, these are the questions where the human still needs to come into the game and give the right data and the right conclusions and to help make the right decisions. And now let's conclude with the kind of like a readiness scorecard for forecasting, because as we saw, the accuracy is only the beginning, right? So it stays on first place. If we don't have it, then we can't really move forward. But still, this is not where we have to stop. It's in a way where we need to start. And then as a second, I have the stability, right? So we have forecasts that need to remain stable as we are approaching the target dates in order for them to be usable and to be adopted by the business. Another thing that I sadly didn't have the time to speak about, but is one of my kind of first or second best favorite topic in forecasting, that's reconciliation. I mentioned those KPIs that we are forecasting, right? Like the demand, the number of items, then you can think the value. So if I sell 5 shoes each for 100 euros, I make 500 euros. But imagine I need to forecast these 3 numbers, and then I forecast something like 450 and 750, something like this. Like if this formula is not matching the actual equation, the actual relationship of my target variables, then again, this is something that cannot be easily adopted because people need to trust those numbers and need to work with them, and the numbers need to make sense. So this is another thing that was very nice to see, that Kronos 2, the way it's built and the way this attention mechanism are used, is making sure that this relationship between the data is learned and preserved even in the forecast. Then, about the sensitivity, so I mentioned that it was crucial that the foundation models are able to take as input future covariates and past covariates as well, equally important. So some things that we are planning, we are lucky, right? Because with the weather, you can't really plan the weather. It's doing what it's what. We are about the business. We are somehow defining the future by making some measures, right? Be it marketing activities, being some more, so giving more discounts because it's we get rid of the stock. It can be whatever, but this is information that we know and we must use, and we need to know that our model is sensitive to this. This is a very hard topic. It goes to in the direction of causal inference, and it's super hard. And then the final one, also super hard. And actually, this is where I started working on since few weeks or about 2 months. I only spoke about the forecast of a general country level. This is used for planning. But at Zalando, we have actually lots of teams doing forecasting. There is another team who is trying to forecast the demand on an article level. An article level means really 500 million of articles for which we need to know the demand, and more importantly, not the demand as a single number, but demand as a scenario, like a demand grid for every possible discount rate. What should the demand for? What is the demand for that article? This is a hard question on its own, and this is something that goes then not to the people to make some decisions, but it goes to an optimizer. So it goes to another model that is then at the end choosing the optimal demand. And here there are lots of open questions, cold start problems, then also the question of how do we even fit all the data in the memory and so on. So I am not sure if foundation models can start helping there, but I really hope that this can happen. So with this, I would like to thank you all for your attention and happy to answer some questions.
Yeah, thank you very much for the talk. And I see already here the first one.
Thank you very much for discussing how forecasting is being used at Zalando. What I'm wondering next is, are there also models that are being used for scenario generation rather than just making a point forecast about the future? And basically, so now once you have forecasted data, so we can do either going to scenario generation, and then the next step would be to using it, right? Like, are there any optimization strategies that are tested with whatever the forecasts are being made in general at Zalando?
Yeah, thanks a lot for this question. So as I mentioned now at the very end, when we speak about article level forecast, this is where we have those scenarios, right? Either you can forecast or build the demand curve that you show with every discount how the demand will change, or you can discretely, so at the moment we have also there a discrete model, that is telling you all these possible opportunities, and this goes to the optimizer. When we speak about planning and this aggregate or top line forecasting, at the moment we don't have scenarios because of the way the forecast is used. So there, kind of the discount rate on an aggregated level, I'd say the average planned discount rate is already fixed as given as a future covariate actually to the aggregate forecasting model. So you can't change it because it's already given. Of course, it could be theoretically nice for the planners to see, okay, if I wanted to change actually what would have happened, but at the moment we don't have this because this is more the task of the optimizer, who is then doing this better on an article level and not on an aggregate level.
Hi. You've shown on one slide that your accuracy levels, like how they are over time, and it looked like sometimes it even got worse the closer you got. So, you know what I mean? So, do you have an explanation for that, or?
This to
Yeah, this one. Yes. So there's somewhere like looks that it even gets worse, like the closer you get to the date.
So this is the horizon. So this means that here today I'm forecasting for this week, next week, then the third week and the fourth week. So I'm forecasting 4 weeks in advance for every week. And then it's kind of, usually it's expected that the further I am in the future, the harder it is to predict.
Yeah.
And then...
Yes, but on some of these it looks like...
it can drop?
Yes.
Yeah. So I think this also depends a little bit on the model that we are using. So there are some models which are predicting, for example, if we think about trees, there we predict every horizon separately, right? And then some models are predicting the full horizon at once. And then it can happen that such a thing... it can happen for a variety of reasons. So one, it can be kind of a model thing that we don't necessarily get always worse when we increase the horizon. And sometimes it can be that some weeks, and I think this is most likely what happened here, some weeks are just harder to predict than others. So for example, for us in the aggregate level, for some reason, obvious or not, it's very hard to predict what will happen around Black Friday, right? So if you had few like normal week, and then, I mean, I can say why it's hard to predict on Black Friday, because you have only one data point per year, and you have 3 or 4 data points in the past. You just have not enough data to able to make some conclusions, right? So if you come to a week like this, then it will be worse even, or maybe that was the first week. I think the other way around, like maybe the first week was Black Friday, so then it was very bad, and the others improved, right? But in general, we don't see this, and that's the reason why we have this complex situation where we have short-term and long-term forecast. So we have, maybe this now already changed, because I think with trees, we saw that we can get rid of this short-term forecast and only have the long-term. But when we had transformers, we would forecast the first 5 weeks with one model. Then we have a long-term model where we forecast next 16 weeks. And there we throw away the first 5 and use that model only from the 6th week to the 16th. But then we had a big problem of stability, because when you are changing from the 5 to the, like when you're changing models, then the weak accuracy will jump by a lot. Not the accuracy, the value. And then we try to find ways to switch to only one model predicting the whole horizon to avoid this.
Okay, thank you.
Hello, thank you for the presentation. I would like to ask if these forecasts are used only for the stock allocation, but also, is it only used for stock allocation, or is it also used for the pricing? So, and if so, do you have different models on top of the demand prediction? Do you have price elasticity models that can feed your markdown, or you are responsible only for the demand prediction part? And one more thing, that if you have different models for apparel and footwear, or generic models are applied for different categories. Thank you.
Thanks a lot for your question. So I hope at some future conference I can give more answers to this question, because that will go exactly to the direction of my new team, where we are doing article level forecasting, right? So in the article level forecasting, actually we have a demand grid. So that means we have a forecasting model for every discount level, and this is discrete. But at the moment we have few research projects where we try to estimate the elasticity curve, which can then be a continuous one. And we will ideally substitute, and then this, either the demand grid or the elasticity curve, will go to an optimizer, right? But it will not be both. At the moment, it should be one. But if we look what makes more sense and what is more useful. Regarding the categories, we do not forecast on a category level. At the moment, we have the two extremes in a way, either the completely market level, where you have the complete assortment of a given market, or in the article level, there you have really CSKU level, so article, and not just article, but including the size, the color, and so on.
Thank you very much for the amazing presentation. I have one question regarding, in one of the slides you mentioned that you tried fine-tuning the model, Kronos 2, and it did not work, or it underperformed, or it did not work well. And it was during a 10-day research sprint or so. Could you shed more light on that? Why it didn't perform well, or was the time period too short, or was the task difficult, or was there not enough data set, or not enough information on how to fine tune? Thank you very much.
Yeah, it's a good question. And I think here, so on one hand, the intuition, understanding the architecture of the model and the way it was built, and the part that I mentioned about the synthetic data, it gives us the feeling why fine-tuning might theoretically not be working. Because if you imagine you have a model trained on 100 billion data sets, and then I come with and if I speak about aggregate level, that means per market, I really have one data point per day. That is, if I'm on a weekly level, these are 52 points per year. So these are 200 points. So 200 versus 100 billion. It's like a drop in the ocean. It's hard to believe that it can bring some value. On the other hand, we were thinking, and the article level forecasting team tried out fine-tuning also on an article level. Here there was one caveat. The Kronos 2 did not allow, now don't hold me for exactly the reason, but there was something about not being able to run on multi-GPU kind of infrastructure, and our data could not fit in only one. And this is where we saw a struggle. But then again, saying this thing with the synthetic data, we were thinking that it could be that these models are really not needing this. But I cannot say for sure, because we did not go beyond those days.
I'm wondering, there's obviously the one component where you have very big numbers, like millions or billions even of sales. And then I would imagine that maybe it's also another component when one of your competitors announces there's a 20% discount for everything. So I'm wondering whether there's any chance to include that to your forecast.
Yeah, I think definitely this is something to take into account, especially when we speak about the article level forecasting, right? On the aggregate level, I think markets, and there in general, even things like inflation, currency, exchange rate, and things like this, we have looked into the past, but they would rarely bring something on the article level. I think this is where it could bring more value, but I think it needs some additional research. And I think here it's again, I know for sure that we have some kind of this scrapping mechanism to even collect this data in the first place, to at least know. But to what extent is used at the moment, I really have to say I don't know.
It's okay.
No, it's fine.
Yeah. Okay.
Okay, yes, yeah, I had the same question regarding to this, but you were mentioned the weather, which of course is covariate to the selling in each country. If there's bad weather, if there's a disaster scenario and something like that, but you make a forecast and then the real data comes in. If you map the real data with the forecast and you see the variations and you see them time over time for different places, because you have your selling points there beside the online platform, what kind of real world data I don't want to list, just what is the important real world data you use to figure out the differences?
Yeah, thanks a lot. Yeah, this is a very good question, and I think it's one of the questions that come from the product, the managers that we have a lot, right? Because it's very kind of appealing to mimic the behavior of, like, if I was now a planner or an analyst myself and I need to provide some forecast numbers, what are the things that I as a person would usually look at, right? And here, for example, the weather is a very big factor, historical data of the last year is a very big factor, then my marketing spend and so on. And these are things that we always try to, on one hand, incorporate in the models.
Yeah.
On the other hand, also investigate on them, just as you are saying and suggesting, with some explorative data analysis. And this is often very counterintuitive, that we see in some explorative data analysis, and we make some investigation on the significance and the correlation between the target variable and all kinds of covariates that we can find or get, which is not always very easy. So I once remember trying to collect the inflation rate. When the inflation rate started going really like crazy, we were thinking, okay, we have to include this because it's such an important aspect. Then corona data we also used to use in the past when there was these huge spikes because of corona period. So then we have to watch out for this and find them. But interestingly enough, not every model is very sensitive to them. And then it was always a question, do we choose the models that are sensitive to this data just because the planners and the product people want to see that we are using them, or we are choosing the models which are not using them but are having higher accuracy, for example? So it's a hard question, but we try to include also the weather. Then the problem with the weather is a prediction itself. So then how much you can trust it, and often it's not the weather itself that matters, but how unusual is that weather. So like differences between the past averages. But now, for example, for the other models where we don't have Chronos 2 on aggregate forecasting, we use a lot light GBM. There, a lot of covariates are self-built in a way. Lots of lag features and so on. And then again, it's hard to convince someone why this is working, but it's in the essence of the model.